Let's talk about simplifying square roots of numbers. In order for you to simplify a square root, it is useful to know some perfect squares. Here I've listed numbers with their square from 1 all the way down to 15 being squared. If you can know that list, it'll make simplifying square roots much easier for you. I've also added in here 20 squared because that one's easy to do. 20 squared, anything with a 0 at the back is going to be easy to do. 20 squared is 400, 30 squared would be 900. So we need to know this list of perfect squares at least down to 15, and then maybe a couple of extras that'll be easy for you to do to help us in simplifying square roots. When we know that list, simplifying square roots becomes much easier for us. For instance, if we had square root of 36 that we were to simplify, notice that 36 is a number that is in our list of perfect squares. We know that the number that you square to get 36 is 6, so the square root of 36 is just 6. That's not so hard if the number we're working with is in our list of perfect squares, but what about if we have something that is not in our list of perfect squares? For instance, the square root of 50. 50 is not in our list of perfect squares. If it were, it would happen right about here. Now, to simplify that square root of 50, what we want to do is we want to come from where 50 would be in the list up our list until we find the largest perfect square that evenly divides 50. 49 won't go into it, neither will 36, but 25 does. I can break this 50 down into its factors of 25 and 2. And when we break it down, we of course mean that we're taking the square root of each of those things. The square root of 25 is just 5, since the number that you square to get 25 is 5. The part on the back I can't do anything with, and so 5 square root of 2 would be our simplified form for square root of 50. Break it down into a perfect square times something else to simplify these. Let's look at another. Here is square root of 32. 32 is not in our list. If it were, it would happen right about here. Coming up from there, what is the first perfect square that will divide it? 25 won't. 16 divides it. So I can break this 32 down as 16 times 2. Square root of 16 and square root of 2. The square root of 16 is 4. Can't do anything about square root of 2, so let's just leave it alone. Even with a big number, we'll do it in the same way. Think of the largest perfect square that could evenly divide 300. 100 goes into 300, so this is the same as 100 times 3. We want to simplify this by making it the square root of each of those factors. The square root of 100, what number times itself gives me 100? That number is 10. I can't do anything with the square root of 3, and so 10 times the square root of 3 would be our simplified. Some tricks from arithmetic that you may find useful in breaking down radicals. If something can be divided by 2, it's got to be an even number, something like 4 or negative 312 or 64. Even numbers can be divided by 2. To know if something can be divided by 3 or not, add up the digits. If the sum of the digits is divisible by 3, then the original number is divisible by 3. For instance, 12. 1 plus 2 is 3. 3 divides 3, so 3 can go into 12. 36. 3 plus 6 is 9. 9 can be divided by 3, so 36 can be divided by 3. 102. 1 plus 0 plus 2 is 3. That's divisible by 3, so 102 is divisible by 3. To check to see if something can be divided by 4, look at the last two digits. If the last two digits are divisible by 4, then the number will be 112. The last two digits are 12. 12 can be divided by 4, so can 112. 10,948. 48 can be divided by 4, so the whole number can be as well. To see if something can be divided by 5, look at the last digit. If it ends in a 0 or a 5, then it can be divided by 5. 15, 20, 355, they can all be divided by 5. Checking to see if something can be divided by 6 requires you to think about two of our other rules. If it can be divided by 2 and it can be divided by 3, then it can be divided by 6. To be divided by 2 had to be even. To be divided by 3, it has to be something where the digits add up to something divisible by 3. 102, it's even. 1 plus 0 plus 2 made 3. That's divisible by 3. So 102 can be divided by both 2 and 3, which means that it can be divided by 6. 366, same thing. It's an even number. 3 plus 6 made 9. 6 more makes 15. Since 15 can be divided by 3, 366 can be divided by 2, 3, and therefore 6. To see if something can be divided by 10, look at the last digit. If it ends in a 0, then it can be divided by 10. 100, 200, 10,000, they can all be divided by 10. And then a big one, 25. If the last two digits can be divided by 25, then the number you're looking at can be divided by 25. 175, those last two digits, 75. 25 goes into 75 3 times, so that means 175 could be divided by 25. Same thing for 225. 25, the last two digits can be divided by 25, so 225 can also be divided by 25. Now, how might that help me in simplifying a radical? Let's look at a couple of examples. 112, the square root of 112. I might not have an idea right off the bat of how to do it, but I do see it's an even number, so I know 2 can go into it. Can we do better than 2? The last two digits are 12. 12 is divisible by 4, so I realize this thing can be divided by 4. Let's break it down by taking a 4 out. 4 times 28 made 112. Now 4 is a perfect square, so square root of 4, that gives me this 2 that I have out on the front. Here I notice though that 28 can also be divided by 4, so I can break 28 down a little bit further. This is square root of 4 times square root of 7. Now again, square root of 4 gives me another 2. So 2 times 2 made 4 times the square root of 7 for our completely simplified form. I took something I didn't know how to get going with and just divided by something that I saw until I could get it somewhere that it would work for me. Look at this big number, square root of 1475. I don't have any idea how to break that down, but I see that 75, the last two digits, can be divided by 25. Now that's a good one to work with because 25 is a perfect square. 25 times 59 gives me 1475. The square root of 25 is 5. I can't do anything with that 59, so 5 times the square root of 59 would be our simplified form. Look for something that will help you get started breaking the numbers down, and then you can find the largest perfect square that evenly divides it from there.